Good morning and afternoon, everyone. Welcome to today's webinar, Building a Modern SaaS Application with MemSQL Helios. My name is Alicia, and I'll be your moderator today. Before we begin, there are a few housekeeping items I'd like to review. Today's webinar is being recorded, and you are currently in a listen-only mode. You may submit any questions you have throughout the webinar via the Q&A or chat function in the lower right corner of your console. We will address everyone's questions towards the end of today's presentation. After today's webinar, you will receive a follow-up email with a link to the recording and slides. If you wish to contact us, please send us an email to team@memsql.com. In today's webinar, we will be determining how to build this modern SaaS application with MemSQL Helios. With that said, I'd like to introduce our speakers, Gim Chua and Dominic Ravita. Dominic brings 23 years of experience across consulting, software development, architecture, and solution engineering leadership. He brings product knowledge and a senior technical perspective to field teams and customers. He has experience in a distributed in-memory data grid, streaming analytics, integration, and data science. Gim has over 2 decades of experience working for Microsoft, Amazon, and Huawei as a software engineer and product manager. He has experience in bringing various database engines into the cloud as a service. Thank you for joining us today, and welcome Gim and Dominic. You now have the floor.
Thanks, Alicia. We're really happy to be here with you today. I'll briefly cover the agenda. So we're going to talk briefly about the requirements of modern SaaS applications and how Helios delivers on that. We'll provide one customer example of that for Helios. And then my colleague Gim will go into one aspect of delivering the capabilities needed for modern SaaS applications. Next slide, please. Next slide, please. So modern SaaS applications, first and foremost, are all about customer experience. In a survey that was done last year, it was learned that you have about 1 second to capture your audience before you have a significant loss of that user. We call this customer churn or conversion, going to the next page in marketing analytics. And that just gives a sense of the speed required to capture users' attentions with modern applications. So there's a lot that goes into delivering that kind of user experience. And you've got to be able to provide this instant experience, this instant responsive, speedy experience, really in an omni-channel fashion through any device. And the data's got to be accurate and up to date, and it's got to work in any locale. And I think we've all experienced applications that do this well, and some applications or mobile apps that don't do this very well. So I want to go into a couple of the constructs of how these modern SaaS applications are delivered. So let's look at the front end first. And with the front end, there have been lots of techniques over the years to provide speedy, responsive applications. We started with pure web applications that were ported to mobile with more efficient CSS and HTML and other web assets. When mobile came around with smartphones 10 to 15 years ago, 2006, 7, 8, 9, we started to see mobile apps created for Android and iOS platforms to provide more instantaneous response to user actions. But the problem with those is that you've got to compile these to each platform. There's a lot of software engineering effort to provide those versions and compatibilities. And what's been popular in recent years is an approach that delivers on the immediate responsiveness and interactivity of native apps, but has the simplicity and portability of web apps. And this is what we call progressive web apps. And you see the link below for the community supporting the progressive application movement. And Technologies that you would use for these kinds of apps typically are React, Angular, Node.js, and you would have a web worker design to help service the behavior such that while the user is browsing your site, with it, be it mobile or web, in what we might call human time, the browser application is running code that does things in parallel and fetches data from the back end so that the user experience is seamless. So now let's take a look at what the back end for this kind of application provides. Now, whereas the front end is going to provide data and web assets, typically, if they're static, they're going to come from a content delivery network like Akamai or Cloudflare, for instance. But the business data itself, if it's fast changing data, that has to be fetched from the data tier on the back end. And typically it's some sort of NoSQL or relational database these days, often hosted in the cloud, maybe perhaps as a service. Secondly, if you're running these backends yourself, then you're running this in a cloud native fashion, in containers or in a container orchestration framework like Kubernetes. Thirdly, the way that the application is designed typically is decomposed into functional components where you have a bounded context with domain-driven design, and that's realized through microservices. And each of those microservices has its own data backend and has its own lifecycle of itself. And then fourthly, they typically, these microservices are exposed to one another through internal APIs. Some of those microservices expose a public interface through a RESTful API. But in general, the idea is that there's an API interface for each of these components. So if we next take a look at what an architecture for this looks like, here's what a typical microservice architecture looks like for an e-commerce application. And this shows the functional decomposition and bounded context of each of these services that compose the e-commerce application. And you'll see customer, catalog, checkout, order as those backend services. And they often have their own persistent store, in this case, a customer database for the customer microservices, a catalog for the query API to query a product catalog, and checkout services for creating an order. So there's typically two modes that we see databases deployed in a microservices fashion, and MemSQL is no different in this case, and where each service, as shown in this diagram, has its own data store just for that particular service, and it follows the life cycle of the service. In other microservices architectures, you'll see another pattern where you have a shared database across multiple different services, and then the logical separation and life cycle is maintained across the database schema design serving those. Both are valid. It depends on the context as to what suits your design. MemSQL suits both designs fairly well. So let's take a look at how Helios delivers on these capabilities. And starting in the upper left, first of all, MemSQL and Helios are scalable relational SQL-focused databases, meaning that we support ANSI SQL, so normal relational joins are supported with full ACID features. It's scalable in that we can provide a lot-free architecture, and such that you get speed and performance, but immediate consistency in terms of the accuracy of data. You're not going to get dirty reads. When you write data, you're going to read that latest data written. That's unlike other sorts of NoSQL variant sorts of databases. So right away, you see that Helios can deliver on speed and scale in a NoSQL fashion, yet give you the guarantees of a traditional relational SQL database. It also supports new styles of data processing and data types, such as document-oriented patterns with JSON. And we'll go into this in more detail a little bit later, as well as geospatial and time series. Secondly, Helios delivers both transactional stores and analytical stores. So for transaction-oriented online applications like taking orders in an e-commerce shopping cart, for instance, that's typically a row store is typically used in that case, as you have lots of individual writes. They tend to be smaller, an order at a time, but there could be millions per second being written. So Helios provides that out of the box. Secondly, it provides a column store that's typically used in online analytical processing use cases, such as complex queries. With other approaches, you've got to use two separate specialized databases for these two different sorts of workloads. With Helios, you can do both in the same application, in the same database, and you can join data across row stores and column stores within Helios. Thirdly, as you'd expect, since Helios is a software as a service, a database as a service, it's elastic and it's distributed. That gives it a low cost of ownership, and it gives it resilience in case of failure. And then finally, Helios works across multiple clouds with AWS and Google Platform, with multiple points of presence in regions, but is Azure, which is coming soon. So I'd like to give you one example of a customer who's used Helios to improve their customer experience, and that's John L. Scott. And they're the largest real estate brokerage in the Pacific Northwest of the US, with about 150 offices and more than 4,000 real estate agents. And so their challenge was, with a small IT staff, how to manage both their website, their property tracker mobile app, and other applications that had real estate listings, and continue to provide that instant customer experience that their users had grown accustomed to, while they're growing listings, while they're growing brokers, without minimizing or without losing performance. The way they were achieving this previously was multiple database types, specialized databases, one for transactions and a separate one for online analytics processing. The problem with that is that there's two technologies to maintain. Often you now have to move data from the transaction store to the analytical store through typically an ETL process. Now you're maintaining that third component as well, and there's latency introduced. So they moved to Helios and collapsed multiple database types, and these were types that were like MySQL and managed Postgres SQL variants, and collapsed both those OLTP and OLAP workloads into Helios, providing them the benefit of a single type of database for these multiple workloads, the elimination of the data movement. Of course, since Helios is a database as a service, there's no database infrastructure to manage. And they got, in many cases, better performance than they were from the workloads running on these separate types of databases, and double-digit cost savings. So with that, I'd like to hand over the presentation to my colleague, Gim, to tell you more about how Helios delivers on these modern SaaS application requirements.
Thank you, Dominic. Like what Dominic described earlier, Helios is a cloud-native database system built from the ground up to leverage the power of parallel processing. Really, Helios is able to achieve this incredible performance and concurrency by automatically distributing and managing your data across separate compute nodes, as you can see in this diagram. Your queries will be broken down, compiled, and distributed to be processed by separate compute nodes by a load balancer, which will then later combine your query results as it comes back in and give it back to your microservice or application. Helios will meet the most demanding performance requirements for any e-commerce microservice. So another advantage Helios provides to e-commerce platforms is that it supports a wide variety of data models, like Dominic mentioned earlier. In the past decade, we've seen the rise of NoSQL databases as a response to relational databases being unable to keep up. Now with Helios, providing the performance, the concurrency and scale, there's really no need for a dedicated NoSQL databases just to gain the performance edge. You can use MemSQL to also support your JSON column type, which Helios supports. And you can define the columns in Helios tables as JSON data types in order to efficiently store and query unstructured data. And this is very common in many e-commerce applications. So why JSON? Well, because it's a lightweight format that's used for data exchange. It's been gaining widespread popularity and is supported by many platforms. And it can be used for converged data processing. So let's take a look at how Helios JSON support can help you simplify your e-commerce data tailor. So before I jump in or dive into JSON, we should start to talk a little bit about structured versus unstructured data. Here I've come up with an example of a structured data. You can see that the data fits neatly into tables with fixed fields and columns. It has a fixed schema and allows SQL queries to be executed for complex joins. In this example here, you can see that user ID 1 refers to the customer Alice in the user table, who has 2 orders of 1, 2, 3, 4, and 5, 6, 7, 8 in the order table. And in the line item table, Alice has 2 product IDs of 765 and 987. And we can see that she purchased 2 packages, potatoes, and 1 package of spaghetti, dried spaghetti in the product table. So, but what happens when your data is inherently unstructured, correct? And this happens very commonly in e-commerce. For instance, the properties of a hand sanitizer, like Germ-X on the left, is very different from a Hewlett-Packard laptop, as you can see on the right. A laptop has a ton more specifications that the consumer may need to view before deciding to buy it, whereas a hand sanitizer really has a lot less. Unstructured data is difficult to deconstruct because it has no predefined model, and it cannot be organized into relational databases easily. Right. So this is where JSON comes in. JSON or JavaScript object notation is an open standard file format, uses human readable text to store and transmit data objects. It has 6 basic data types: string, number, Boolean, array, object, and null. And the format is shown on the right. It's very easy, and it just consists of key value pairs and array data types. So I just grabbed an example off the internet. Here's that you can see what an unstructured data stored in JSON looks like. Here's a device that has a front-facing camera, has a battery that can last 24 hours. The camera can support both flash and video, and has 5 megapixels, and so on and so forth. As you can see, it does not easily fit into a relational table where the fields have to be predefined. So how do you create JSON columns in Helios? Very simple. When you execute or create table command, you can specify a JSON property just by using a JSON tag, correct? Optionally, you can also specify not null. Using not null suffix is actually recommended because it causes Helios to give an error if you try to insert an invalid JSON. I also want to talk a little bit about indexing JSON columns. They're not indexed directly, but they're indexed using computed columns. So if you want to see the best performance, you really should not use JSON built-ins, the : notation in your filters. Instead, you should create a computed column that includes the JSON column, and then use a computed column for the index. In this way, the index gets updated only when the relevant JSON data is updated in the row. So how do you add data to a JSON column? I've actually created a Helios database, and what you see here is our MemSQL Studio, which allows you to conveniently connect and execute SQL queries, as well as see what's happening to your database. So the create table command that you've seen earlier, I can just simply highlight and run it. And then the command to insert, or the SQL query to insert data is simply this command here. And we're going to insert these two data elements with JSON in them. And then if I do a select query from the catalog table I just created, you will see that it returns the lines, the rows that have been inserted, and it has pulled out the JSON values into the computed columns here. As you can see, the weight and color. So other commands you can use along with JSON include update and load data. Now to access a field in JSON object stored in a column, you can use the name of the column suffix with the : and then the key name. You can transparently convert a JSON string into a SQL string, and then use the name of the column suffix with the : $key name. Likewise, for numbers, you just, instead of the $, you use a percentage symbol. So and then MemSQL Helios also provides a comprehensive list of JSON convenience functions that can help you access and manipulate your data in JSON. You have functions to manage arrays, delete keys, extract data types, find length, splice, and set data, etc. I highly recommend that you go into our documentation. It is out of scope for me to actually go into each and every one of these functions and explain how they work. So the next section, I want to talk about some of the unique behaviors, unique JSON behaviors in Helios. Specifically in handling infinities and not numbers, Helios does not support such entities such as NEN. Although the JavaScript language supports NEN and positive and negative infinities, neither the JSON standard nor the SQL's double type provide any way to represent such non-finite values. If your application requires these special values, you might try using null, 0.0, or strings in their place. And then for Unicode support, JSON strings can contain any Unicode characters in the basic multilingual plane, but Helios does not support characters outside of this basic multilingual planning. This includes some uncommon Chinese characters and emojis. And if you attempt to insert or use JSON entities containing these characters, they will be rejected and cause Helios to make these entities become SQL null instead. Under the hood, JSON is stored in Helios as long block columns. As a practical matter, the size and limit of the JSON value is bounded by the max allowed packet variable. And then lastly, collation provides a set of rules when you are doing comparisons. By default, JSON columns in Helios use the UTF-8 bin collation, which is case sensitive and sorts by Unicode and code point value. The collation of the JSON column affects the following, output of select, distinct, or order by and other queries that compare entire values, identification of duplicate keys inside a JSON object. The UTF-8 bin collation generator provides the desired behavior. However, you can actually override this default at the table or column level. So I hope that you can see how Helios can not only provide JSON support for your e-commerce platform, but can also give you the fastest API performance for your progressive web apps to provide that fast, fluid response to your users, while being able to handle the concurrency of thousands of customers at the same time. When you need more speed and power to handle more customers, you can not only scale up or down on the fly with no downtime to your e-commerce platform, you can also scale out your Helios to handle your e-commerce growth in the future. And because Helios is fast enough to handle huge amounts of data, you don't need dedicated NoSQL databases for speed. You can consolidate all your dedicated databases into a single Helios database for ease of software development and operational manageability. Your developers no longer have to do programming tricks just to pull data from different databases, sources to do complex joins. Your DBAs no longer have to have expertise in half a dozen or so different database engines just to maintain and manage them. You can manage one Helios database from one management portal. And that's it. I hope we've provided you with a taste of Helios and how we support JSON for you to want to actually try it out in your e-commerce application. I will now turn over to answer your questions that you submitted.
Thank you for your presentation, Gim and Dominic. We will now begin the Q&A portion of today's webinar. So as a reminder, you may submit questions through the Q&A function located in the lower right side of your console. So some questions have already come in. We can start with this one. How does backup and restore work on Helios?
I can take that question. So there are several ways you can do backup and restore. First, through the backup and restore commands. In Helios, you can back up to either S3, Google, and Azure blob storage. Helios also takes a admin backup of your database every day at 2 a.m. your local time. And keeps that backup for 7 days. So if you need to restore your backup, or if you have not taken any backups, you can actually file a ticket, and we will restore your data from the backups that we have collected for the up to the past 7 days.
Great, thank you. Is the disk storage adjustable for the cluster size?
Right now, the short answer is yes. In Helios, we have the concept of a unit, and each unit has a fixed storage size of 1 terabyte. It also has 8 vCPUs and 64 gigs of RAM. But if you need to resize your Helios cluster, you increase it in pairs. So you can, because of high availability, your data is redundant. A copy of your data is redundantly stored across a different partition, and so you can increase your the size or decrease the size of your Helios cluster in pairs of Helios units, and each unit has 1 terabyte of storage.
Thank you. How does Helios support ACID over a scalable database?
Dominic, you want to take that one?
Right. So Helios is an ACID database, and performance-wise, in benchmark testing, we've seen this with we've done independent benchmark testing, which you can find on our blog, with the relevant standards of TPC-DS, TPC-H, and TPC-C. And we find fantastic performance for MemSQL, where in general, we see that for most standard single node traditional legacy databases, we're getting about 10 times the performance at about a third of the cost. So with Helios, we manage lots of different workloads in different customer environments, but we're deploying that across zones of AWS and GCP. So your mileage and your particular workload and app is going to vary based on the characteristics of your environment. But we've seen our own benchmarking test held up in various different customer environments that are within that same order of magnitude in terms of performance advantages.
Thanks, Dominic. What kind of SLA does Helios guarantee?
Currently, Helios guarantees 3 nines of SLA, and we have monitoring systems to monitor that. So this is pretty much an industry standard. Most managed databases, as you'll see with, for instance, AWS RDS, they also have 3 nines of SLA guarantees.
Thank you. Okay, and we have a couple other questions. How does performance look like compared to other databases in the market? And do you have any performance stats?
Well, I think I just answered that question. You'll find on our blog the benchmark that we've done, and with each release we're improving performance, and we're soon to release 7.1. Each of these releases we're tuning performance for both our transactional and analytic capabilities. And we continue to stretch that performance advantage compared to traditional single node databases, both that are deployed as managed services like managed Postgres, managed MySQL, and the variants of those that we find across various cloud platforms, as well as traditional on-premise single node apps that may be using sharded middleware or dedicated proprietary hardware to scale. In all of those cases, Helios and MemSQL, which is the underlying the code base on which Helios is built, has the advantage of using commodity Linux machines that help us to get that advantage, plus the architecture itself and our techniques for data storage, as well as our query execution and optimization advantages.
Thank you. How does Helios function with regard to data consistency? And is it strongly consistent or eventually consistent?
I'll take that. So MemSQL and Helios are databases that provide immediate consistency. So although we provide many of the same functionalities you would find in a NoSQL distributed database, and allow you to store objects like JSON documents, raw and natively, we also provide the robust semantics of relational SQL such that you actually can combine these techniques. And this is why we say that in many cases, to handle the spectrum of workloads needed in modern SaaS applications, you no longer have to manage multiple specialized databases for each of these workload types. You can have your cake and eat it too. You can get the speed and scale that you need, which for years the industry has needed to break the relational constraints with NoSQL types of stores, from in-memory data grids, transactional caches, inverse indexes, things like that for search indexes, or key value stores to get the speed and scale needed. No longer do you have to give up on the relational SQL to get the other two. So MemSQL Helios delivers on all of those.
Incidentally, we actually have an excellent blog written by our VP of Product Management, Rick Negrin, on that very precise topic of how you no longer need NoSQL databases. I would highly recommend everybody to go actually look up that blog posting on our website.
Thanks, Gim. Thanks, Dominic. Thank you, everyone, for all of your questions. If you have any additional questions, please send us a note to helios@memsql.com, and we'll be sure to answer. We also have a short survey followed by the close of the webinar, and appreciate your participation if you can stick around for an extra minute or two. I want to thank Gim, Dominic, and each of you for attending today. Just a reminder, we'll be sending you a follow-up email with a link to today's recording and slides. If you have any questions in the future, again, you can send us an email to helios@memsql.com. We invite you to learn more about MemSQL at memsql.com, or you can get started with your trial of MemSQL Helios at memsql.com/Helios. Again, thanks for participating and have a great remainder of your day.